Hello everyone, I welcome you all to Startup Academy, your online gateway to get success in ISS exam. This academy is exclusively for ISS only. And in the previous lecture, we have started with the new topic of statistics paper 3, which is index numbers. And today we'll continue with the unweighted average aggregate method of index number. First two we did yesterday or in the previous lecture, which was last pair's index number and past list index number. Today we'll do the rest four index numbers. So let us begin. So A and B last pairs index number and B past index number. This we did in the previous lecture. If you haven't seen that, you can rewatch that. Now the third one is Marshall Edgeworth index number. Now, what is Marshall Edgeworth? Firstly, we'll write price index number of Marshall Edgeworth, then we'll write quantity index number. We are dividing this into two halves. Here we'll write price and here we'll write quantity. So in Marshall Edgeworth, the weight Wi is nothing but the average of Q naught I plus Q1I upon 2, the average of the quantities. So in price index number, we can say that I01 of price, the Marshall Edgeworth is written by summation P1I Q0I plus Q1I upon 2 upon summation P0I Q0I plus Q1I upon 2 into 100. So this is our price index number of Marshall Edgeworth price index number, where weight is the average of the two quantities of the current year and the base year. Now we are writing the quantity, the Marshall Edgeworth quantity index number. So here weight would be equal to average of price of the current year and price of the base year. So this would be equal to I01 Q equal to summation of Q1I P0I plus P1I upon 2 upon summation of Q0I P0I plus P1I upon 2 into 100. So these are the two Marshall Edgeworth index number, price index number and quantity index number. Now going forward to the fourth kind of index number, which is Walsh index number. Now what is Walsh index number? Again we'll divide it into two halves. First is Walsh price index number, then second is Walsh quantity index number. So what is Walsh price index number? Here weight will be equal to the geometric mean of the quantity, the base year quantity and the current year quantity. You know that geometric mean of n variables are n1, n2, n3 up till n raised to the power 1 upon n. we can write it here. If we have to find the geometric mean of these many, like we have n1, n2 up till nk quantity. So geometric mean of these would be n1 into n2 into up till nk whole raised to the power 1 upon k. This is the geometric mean. Since we have only two variables here or two quantities here, so geometric mean would be 1 by 2, and 1 by 2 can be written as under root 2. So this is the geometric mean. Wait. Now the price index number can be written as I naught 1 p equals to summation p1 I under root of q naught I q1 I upon summation p naught I under root of q naught I q1 I into 100. Now similarly the quantity has the Walsh quantity index number has weight under root of p naught I, which is the price of base year, and p1 I, which is the price of the current year. And we can write the index number 01IQ equals to summation of q1I. This summation is over I. Everywhere this summation is over I under root p naught I into p1I. We can directly write it p1I upon summation q naught I under root of p naught I into p1I into 100. So this was our Walsh price index number and Walsh quantity index number. Now moving forward to the third type of index number, which is fifth type of index number, which is Darvish-Bowley index number. Again dividing into two parts. Now here it will be price Darvish-Bowley price index number, and here it will be Darvish-Bowley quantity index number. So Darvish-Bowley is the average of last year's and past year's index number, and here we can say that average of last year's and past year's price index number. So what were the last pairs and past year's price index number? If I write about last pair, it was P1I Q naught I upon summation of P naught I Q naught I into 100. We are ignoring that for now. And past years is summation of P1I Q1I upon summation of P1I P naught I Q1I, and it is the average of these two, so I will write 1 upon 2 into 100. We are multiplying 100 just so that our calculation becomes easier, or our final outcomes is easier to interpret. If the values comes out to be 0.035, then we won't be able to tell, but if the value is 3.5, then we can easily compare our values. That is why we are multiplying it by 100. So this is our price index number of Durbin-Bowley. And for quantity index number of Durbin-Bowley, it is average of last pairs and past days quantity index number. Now I am writing first last pair, which is P, which is Q1I P naught I upon Q naught I into P naught I plus summation of, now purchase quantity index number is Q1I P1I upon summation of Q naught I P1I, and since is the average value, we'll divide it by 2 and multiply by 100 for easier calculation. So this is our quantity index number of by Darvish-Bowley quantity index number. I hope that it's clear for Darvish-Bowley quantity and Darvish-Bowley price index number. Now the sixth and the last one is Fisher's index number. Now Fisher's index number is also known as Fisher's ideal index number. We'll discuss that later, but first of all, what is Fisher's index number? Fisher's index number is the geometric mean of the last pairs and past shares index number. So again, we are dividing into price and quantity. Here we can write it is the geometric mean of last pairs and past shares index number. Now what is price, Fisher's price index number? Since we know that last pair is summation P naught, summation P1I Q naught I upon summation P naught I Q naught I. This is last pair, and summation P1I Q1I upon summation P naught I Q1I. This is past share. So the geometric mean of this, which is this, is the index Fisher's price index number, and we'll multiply it by 100 for our easier calculations. Now the quantity is similar to this, just it's the quantity, last year's quantity index number and past year's quantity index number. I01Q is equals to under root of summation Q1I P naught I upon summation Q naught I P naught I into summation Q1I P1I upon summation Q naught I P1I into 100. So this is Fisher's quantity index number. So ideal index number, after this we'll start with the topic of testing. We have found out the index number, now we have to test whether the index number are satisfying or not with some test. There is only one index number, which is Fisher's index number, which satisfies all the tests, and hence it is known as Fisher's ideal index number. The test we'll do in the next lecture. Till then, you can revise these six index numbers, and they are very easy to calculate and to recognize. If you face any doubt in any of the topic, then you can ask in the comment section or on the WhatsApp channel, and keep on working hard. All the best. Thank you.